Welcome to part 2. So in this part, we will look into ideal gas for single gas, where we can use the equation in ideal gas in this section to find unknown information such as P absolute, T absolute, volume or number of mole for ideal gas system. Okay, let's say, so under ideal gas, we have the equation which is PV equals to nRT, and this equation is, the name of this equation is ideal gas equation of state. So you have seen this equation before in other subjects. So the equation that for ideal gas is PV, P pressure, V volume, P pressure, V is volume or okay, we have two equations. We have PV equals to nRT, or we can use PV dot equals to n dot RT, where P in this equation means P absolute, pressure of the gas, where we can find P absolute equivalent to P atmospheric plus P gauge. Okay, V or V dot is actually volume or volumetric flow rate of the gas. N or N dot is number of mole or the molar flow rate of the gas. R is the gas constant. You can find the gas constant at the end or at the back of your textbook. Okay, please go and check. See, there are several gas constant that they can use in this equation depending on what types of units that being given as your information. So you can choose your gas constant. And then T in this equation means the absolute temperature of the gas. This equation can be modified into, modified into PV with the hat equals to RT, where V the hat, or known as specific, this V with the symbol here means specific molar volume of gas, where specific molar volume of gas is equal to V over N, or V dot over N. To check whether our assumption of ideal gas is correct, so we have to do this calculation. Okay, sometimes because ideal gas equation of state is actually approximation, so we need to check whether it's correct to use this ideal gas for the condition that we are given. So we have to check to check our assumption. So what we have to do is we have to use this equation. If we have diatomic gases, for example, we have nitrogen, oxygen, chlorine gas, so we use this equation, V specific molar volume ideal equivalent to R, T over P is greater than 5 liter per mole, then it is ideal gas. For other gases, you have to use this equation. V ideal equals to RT over P greater than 20 liter per mole. If you have greater than 5 for atomic gases, if this ratio greater than 5 liter per mole, that means it is ideal gas. If it's greater than 20 liter per mole for other gases, it means it's ideal gas. If it does not comply, which is less than for diatomic gas, less than this value, and for other gases less than this value, then maybe the non-ideal gas equations are more suitable to find the information for that single gas system. Another condition to check whether your assumption of ideal gas is correct is if you are given the true value, and also you have the calculated value using the ideal gas equation of state. So you need to find the error. Okay, this E here is the error. Okay, this is equation error equivalent to the value that you obtain using the ideal gas equation of state minus the true value given to you, the true data, divide by true data times by 100. Okay, if you get less than 1%, that means your assumption of ideal gas is correct. Because if your error is less than 1%, that means it satisfies this error 1%, less than 1% satisfy the condition for V ideal for if for the case of diatomic gases. That means if less than 1% for diatomic gases, that means you have more, your ratio between R times T over P is more than 5 liter per mole. And if is case for other gases, that means this ratio is greater than 20 liter per mole. That means if you get the less than 1%, that means your assumption for ideal gas, your system for ideal gas is correct.